is requirement elicitation. And in the requirement elicitation, I mentioned that in here, the main objective is the need of the stakeholders and what the stakeholder is expecting and what is basically is the outcome. Yeah. So you start with the need of the stakeholder, what is expected, and what is the outcome. Yeah. So that is the in a requirement elicitation. On the other hand, the system requirement. So this is for unstructured. It's not very structured way. It could be some simple stuff through interview. Whereas in the system requirement definition, now you have a structured and formalized way of saying what the system shall do. Yeah, so what the system shall do comes at this stage. Here is what the customer needs. And then I talk about the tools required for requirement management. And then I mentioned some couple of tools like DOS, MSOSA, which is sorry, the DOS and TRM and Simulink as a tool which I kind of showcase. And then I move into the system architecture design. So it means in the left side of the V, so we have finished the top part, and in the top part, we look on this system engineering activity. So once you have finished the system engineering activities, it means now you have outputs and artifacts to give to the software team now to turn those requirements into the software which can be deployed into a vehicle.
Dr. Hoffman?
Yeah.
Maybe just to interrupt you, maybe there are some students who have questions before you proceed.
Yes, please, yes.
Is there any question for the first two topics? Or any question? Okay, no question, please proceed.
Okay, so am I too fast or too slow?
We have like 30 minutes now.
Okay. Yeah. So I was trying to gauge the pace, and I know that some of this terminology may be new to the students, but again, the objective is to give you an insight of what is happening, and what it takes to make a product ready. Okay. Yeah, so moving on to the software engineering aspect, still we're in the left side of the V. So in the software engineering, so we move into the requirements, and then we look in the software architecture design, and we look into the detailed unit design construction. So the software requirement define how the software should behave to meet the system requirement. So if you remember when I said about the system requirement, I say it defined what the system shall do, and the software requirement is say how the software should be implemented to meet the what of the system requirement. So the key thing to remember here is the software requirement is talk about how, and the system requirement is talk about what need to be done. Yeah. Okay. Just to give you in a layman terms, you could think about what I want. You may say, I want a cup of tea with sugar. That's what I want. Yeah. As a requirement, I want a tea with sugar, no milk. But the how is how am I going to cook it? How will I prepare that tea so that can be available for you to drink? Yeah, so that's in a simple term, in a layman term, that's kind of how we interpret the software requirement. So now the software requirement usually is obtained by the composed high-level system requirement. So the first thing you will have is high-level system requirement, and you'll turn out on how to achieve that, okay? So which means back to the simple layman example, and then I'm gonna go to the proper example, is now you say you need a cup of tea. What you need is a cup of tea with sugar. And then how, it means I need to cook it. So it means I need to have a fire. I need to have a cooker or a fire. I need to have what do you call it, water. You know, I need to have a tea bag. I need to have a spoon of sugar. So now you see the what is one, like I need a, you know, cup of tea with sugar. That's the what is just one requirement, but the how is becoming too many requirements. Means you start saying, oh, I need, you know, I need to have a cooker to do that. I need to have a water. I need to have, so you start having multiple stuff. Yeah. So which means in the software requirement there will be more um, system requirement. Okay, and then moving an example, just let's just look at this simple example. So just this one, I picked this example because it can link with your course as well. So if you think of the DC-DC converter, so the requirement of high-level system requirement, you could say the DC-DC converter shall regulate output voltage to 12 volt with a tolerance of plus or minus 5 volts. Yeah, while operating with an input voltage range of 300 to 800 with a varying load condition. So you can see the high level requirement, but it got a lot of things going on here. So the requirement asks you to regulate around 12 volts with a tolerance of that based on these inputs. So you know that this type of converter is going to be a back converter. So which means that it will take 300 volts and it will step down to 12 volts, or it will take 800 and it will step down to 12 volts, which means with the varying load conditions. Yeah. And also we need to make sure that we have some tolerance in between. So that requirement of the high level, so I'm kind of decompose this one into a small chunk, just focusing on 12 volts first for now, and ignore the varying load. So I refine that requirement and I say that, okay, I want to regulate output voltage to 12 volt with a tolerance of plus or minus 0.5. Yeah. So now to achieve this, I need cap of the software requirement. So the first, I may need to have a control system which will allow me to regulate. So which means I need to say that the software shall implement a closed loop voltage control algorithm to maintain output voltage of 12 within that. Yeah. So it means to achieve this, I need a closed loop control system. And then I may need to have another requirement. I also need to monitor the input voltage in real time. Yeah, to adjust with the duty cycle. I may need to have another requirement, which is talking about what operation or the frequency which this converter need to operate. Yeah, so the software shall operate voltage control loop with a sample rate of 10 kilohertz to ensure stability and responsiveness. Yeah. So you see the requirement is to regulate, which is one requirement, but turn up into multiple software requirements. Yeah. It could be like, okay, the software shall provide configurable reference voltage. Okay. And so on. You could also have on what type of controller to use. So we may say that, okay, we may need to use PID controller. Okay. And make these parameters tunable for PI and D terms. Okay. So now, as a part of high level requirement, I say, how do I handle the varying load conditions? Okay. In varying load conditions, I may need to come up with some additional requirements. So I may need to say, like, I need to be able to monitor the output current, ensure that it does not exceed a specific rated value. Yeah. So which means I'm trying to put some constraint, to ensure that I'm supporting the varying load conditions. Also, I need to think about other software requirements. So now, just to give you an insight, so the system engineer, what he will give to a software engineer will be high level requirement. And the high level requirement is the one which I showed you before, which say that, okay, we want to regulate the voltage to 12 volts, yeah, for the varying load condition with an input of 300 to 800. So that's the requirement the software engineer will receive. So the software engineer need to decompose that into these software requirements. Sometimes you may have a system engineer decompose that to the software team. Yeah, so it's not a fixed. It depends on the organization. You could have a software engineer decompose for themselves, or the system engineer decompose for them to get the requirement which can be implemented, because these are the ones which turn them into software. Okay. And you may have another requirement. You say that the software shall be able to detect the transit load changes and respond within 1 millisecond. And you can see that the software requirement, they are talking exactly how. Okay. If back to the standard example of saying that the customer say, I need a cup of tea with sugar, he does not really specify how he wants you to heat that temperature. What are the temperature need to heat the water, to have a red tea, how warm the tea should be. So the how and all of that come as a part of the software requirement. Okay. So there's another example, but I'll speed up on this one example. From the same requirement, you could see on how you detect the faults and recovery. You could have those requirements. I'm just rushing on these ones. I meant to skip this slide. You could say on how you operate under thermal conditions. Again, is a high level requirement, and then you decompose that. Pretty similar example to the previous one. How you do the comms, again, you decompose those to different software requirements. So in summary, software requirements, the high-level system requirement result into many software requirements. Is unlikely you have one-to-one mapping, but usually one high-level system requirement may result to multiple software requirements. And then you implement all of this to make sure that you meet this requirement. Okay. So now, once you have your software requirements, those are the input to define your software architecture. So the software architecture is a blueprint. Yeah, so we call it blueprint for software implementation, which ensure that the software is modular, maintainable, and compliant with the safety, security, and functional requirements. So that's the key thing. So once you have the software requirement, then you architect that to get your software architecture. And then in this case, you move on. You use some different tools to do that. So you could architect the software using tools like MATLAB. So MATLAB has something called MATLAB System Composer. You have some other tool like Enterprise Architects. You have CATIA Magic. You got System Desk, which is the DSpace tool, and so many other tools. Similar, I talk about the requirement to have TRIM, DOS, and all of that. So for the architecting, you have multiple tools. And some of these, or majority of these tools, they are not taught at the university, so you tend to find them when you move to the company. But MATLAB System Composer should be available if you are using MATLAB in your school. That toolbox should be there. So what are the key objectives of architecture design? Again, is to define the software structure and allocate the software requirement. You define the interfaces, and you make sure that all the non-functional properties have been met. And there's the traceability. So traceability is the key. So the software architecture need to be traced back to the software requirements, and you need to be traced to the software, to the system architecture as well. So this is an example of the throttle control composition. So this is the software architecture of the throttle composition. So you have multiple subsystems, and these subsystems we call software components. Yeah. So in order to calculate, to get your actuation of the throttle position, you need to have this software component interact.